Okay, well, let's begin. Good morning, everybody from across North America and around the world, and welcome to today's presentation called Designing PEX Plumbing Systems to Optimize Performance and Efficiency. This is a presentation by the Plastics Pipe Institute, which is an ASPE CEU provider, and this is an accredited course according to ASPE. And again, thank you very much for joining us here today. A copy of these slides is already posted to the Handouts tab within this GoToWebinar, so you can download the slides that way. And there's also a copy of the slides posted to a BCD webpage. If you go to the website shown at the bottom of this slide, and then click on the Education tab, and where it says Presentation Slide Decks, you can download the slides from there as well. The recording of today's presentation will be shared on LinkedIn within a few days, and will also be posted to a PPI webpage within our Building and Construction division called Education and Recorded Presentations. If you would like a certificate of completion for today's presentation for ASPE CEUs, please send that in via the chat function. Or if I back up a little bit here to the first slide, you can see my email address, lmacnevin@plasticpipe.org. Just shoot me an email and I can generate that certificate after the presentation. I better do a quick introduction. So my name is Lance MacNevin, and I'm the Director of Engineering for the Plastics Pipe Institute's Building and Construction Division. Been working here full-time since 2015. I am a staff engineer, and I focus on coordinating research, technical publications, education like today's events, advocacy, and various types of outreach. I've been in the plastic piping industry since early 1993, and I am fortunate that I get to serve on technical committees within lots of great organizations, such as those shown here, and those are standards development organizations and code bodies and certification bodies and more. So that's a little bit about me. We actually do have a few poll questions that we're going to be launching here in today's presentation. So the first poll question is actually going to ask everybody on the webinar to identify who you are. So let me launch this, and we'll keep this open for about 45 seconds or so. And we'll ask you to check the box that most closely identifies your involvement with the plumbing industry. I know there's lots of other possibilities for different types of audience members that could be on the webinar, but GoToWebinar allows 5 choices. So these are the 5 choices that I was hoping would represent almost everybody. Okay, very good. Thank you for responding. I'm going to close the poll now, and then we'll share the results really quickly. And it looks like we have a lot of plumbing component manufacturers on today. Welcome, and some plumbing engineers and distributors and reps as well. So thank you, everybody, for joining. Quick introduction on the Plastics Pipe Institute. PPI is a nonprofit trade association that was originally formed way back in 1950 to research and develop test methods for plastic pressure pipes. Yes, plastic pipes have been around since the 1950s, so PPI has been involved since the very early days of this industry. And today, as I mentioned, PPI is a nonprofit based down in Irving, Texas, and we serve all of North America, although a lot of our publications and our content ends up being used by people around the world as well. Our mission is to advance the acceptance and use of plastic pipe systems to research, education, technical expertise, and advocacy. So this is one of these goals of our mission, is to do presentations like this. And we are supported by over 170 member firms involved with the plastic pipe industry that pay dues to belong to PPI to support our mission and to support this work. PPI has 5 divisions. So everything related to plumbing systems is represented by the Building and Construction division, or BCD. And BCD is focused on plastic pressure pipe and tubing systems used within buildings and on building premises for a big list of applications that you see here. But plumbing is obviously one of our primary applications that we focus on, and that's what we're going to be focusing on today. The materials that we represent are also shown here, and that includes alphabetically CPVC, high-density polyethylene, PEX, PERT, PEX aluminum PEX, and polypropylene. But today's presentation is obviously focused on PEX for plumbing. If you want to go straight to our homepage where you can get access on these materials, simply go to plasticpipe.org/building construction. And this image at the bottom is kind of a family picture of the different piping materials that we represent within this division. So a bit of a course introduction. Let's start out with this and say that as a result of modern polymer technology, PEX tubing performs in ways that provide superior reliability, durability, and safety. PEX tubing has been used for plumbing systems in North America for over 25 years, providing safe delivery of potable water and protecting the health of building occupants. PEX systems are widely accepted for residential applications and are being adopted more and more for multifamily and large-scale commercial plumbing applications, even high-rise facilities, where commercial plumbers and commercial engineers are seeing the benefits of PEX plumbing systems. So this course is going to demonstrate how the properties of PEX systems can protect the health, safety, and welfare of building occupants through efficient and reliable delivery of clean drinking water, and how to specify and design PEX plumbing systems to optimize performance and efficiency. So that's a lot of content. But before we get started, just a little bit of background information in terms of how accepted is PEX plumbing systems in North America today. Well, we're able to get access information from the Home Innovation Research Labs that issues a report every year called the Builders Practices Report. And the version of this report from September 2021, which is basically a survey of all the major builders across the United States to ask them what types of materials they're using for construction. This report indicates that as of that time, as of the year 2020, more than 60% of all new homes are actually using PEX for plumbing systems. So PEX is really a proven success, and it's now the dominant material used in residential plumbing. There is no such report like this that applies to commercial plumbing. The scale of PEX being used in commercial plumbing is not quite at this level yet, but it is heading that way, and that's why we're here, is to support that adoption. So some course background to know about. Much of the information in this course is actually taken from this document here called the Design Guide for Residential PEX Water Supply Plumbing Systems. And this document was published 10 years ago. The primary publisher was Home Innovation Research Labs, but content also came from PPI and PPFA and ICC. This document is a free download. You can also order a paper copy, a printed book copy if you like, through Amazon or through our website. But if you just want to download the PDF file for free, you can do that directly from our website. Some other information to know about when we talk about designing PEX plumbing systems and sizing pipes. We're going to get into that in more detail in the second part of this presentation next month. But there is an online calculator that is intended to help with sizing pipes properly. So we call this the PPI Plastic Pipe Design Calculator, and you simply go to plasticpipecalculator.com. It's a free online app that anybody can use, and it does these 6 major types of design functions or design calculations, from pressure and head loss to hydraulic shock, pipe weight volume, thermal expansion. It'll also help design expansion arms and loops, and then even calculate static water column pressure for tall columns of water. So this was launched in 2015, and it's a very popular tool. And it works for PEX and CPVC and polypropylene and PERT and other plastic pipe materials as well. Before we get into the course content, let's just touch really quickly on the reasons to select PEX plumbing systems. And there's a lot of them from our perspective. This is a big list of advantages for PEX plumbing systems. So I'm not going to read all of these to you, but the number one is safety. It's got resistance to scale and mineral buildup. It has freeze break resistance, and we'll talk about that a little later. A smooth wall, so you get excellent flow. It's resistant to corrosion and erosion and water disinfectants. It's quiet because of the thicker wall that absorbs pressure surges, and that's also because of the flexibility, which helps to reduce water hammer in case of a fast closing valve. It's flexible, as we're going to demonstrate in today's presentation, very flexible. So this can facilitate faster installations, which saves time and money. There's many fitting and joining options, and there's no hot work risk because we're not using torches to join PEX pipes with fittings. It's lighter weight than copper or other types of metals. So that means it's really easy to transport and much safer for workers on the job site, especially when we're talking about larger diameter pipes. We can actually conserve water with PEX plumbing because there's less heat loss through the pipe wall, and the longer lengths of PEX tubing can actually reduce the number of fittings and again, speed installation. And then what we're going to demonstrate today is that PEX tubing systems have a proven long life with rigorous certifications, and they are highly tested. So they are very safe for use. Now, some other reasons, and this has to do in the field of sustainability. A lot of people are concerned about this today with circularity and sustainability and environmental impacts of various materials that we choose to use. And PEX plumbing systems are really a big winner and really, in our opinion, cause the least harm to the environment as compared to metallic plumbing systems. So there's no mining operations to extract the ore from the ground. There's a lower cost to the environment for production of PEX. There's reduced water consumption for manufacturing PEX compared with metal. The lighter weight, again, reduces transportation costs and more benefits. And one way of summarizing those benefits is through a life cycle analysis report, or an LCA. And a couple of years ago, the organization known as TEFA published an LCA of PEX versus copper, directly related to plumbing applications. And we're not showing the whole details here, but the graphic in the lower left kind of indicates the scope of the environmental footprint of PEX versus copper. And then the graph in the lower right indicates the 7 major environmental impact criteria that are measured and how the impacts of PEX compared with the impacts of copper. And in all cases, you can see that the impacts of PEX are far lower than the impacts of copper. So PEX really can be demonstrated in this way to cause far less harm to the environment than using metallic plumbing systems. So it's a big winner in that sense. Okay, let's introduce our course learning objectives. Now, this is actually part 1 of a very long course. I shouldn't say very long, but a somewhat long course, because there's a lot to say about PEX plumbing systems when we get involved with design and installation and all the properties and things like this. So today we're calling this the part 1 course, and today we're going to focus on the first 3 learning objectives here. So by the conclusion of this course, participants should be able to explain how the properties of PEX tubing and fittings can protect health, safety, and welfare, and that's going to really introduce the properties as related to that. Number 2, introduce several options of PEX fitting system designs, and there are several to choose from. And number 3, to discuss PEX system standards and code compliance. And for number 3, we're going to get into the details of the standards requirements so that everybody understands how tested and how rigorous these standards are for PEX systems. The other three learning objectives are going to be explained in the follow-up webinar, which will happen a month from now. And we'll talk about that in our very last slide. So let's get right into it with learning objective number 1, which is how the properties of PEX tubing and fittings can improve health, safety, and welfare. So this learning objective will explain the properties of PEX system components. Part A, we're going to focus on the tubing. Part B is going to be on the fittings. And part C is going to be on plumbing distribution manifolds, of which there are several different designs and materials used. So let's get started with this. And the best way to introduce the properties of PEX tubing is actually to refer you to an existing publication that was recently updated. On the PPI website, we have a document known as TN17, or Technical Note 17, that was first published in 2001, I believe, but recently updated in 2021. And you can see by the table of contents here the different types of content that you will find in this TN17 document. So it's a great reference. I'm not going to read that to you, of course. I'm going to touch on some of the highlights of information that you'd find in that document, but we definitely refer everybody to TN17 to be able to get a really nice written summary of this type of information for PEX tubing systems. So let's give a quick definition first. And the formal definition of what is cross-linked polyethylene is shown here. It is a polyethylene material that has undergone a change in molecular structure through processing, whereby a majority of the polymer chains are chemically linked. And that definition is actually found in 2 different ASTM standards. ASTM, you probably know, is the American Society for Testing and Materials, an organization that is 125 years old now. And you'll find that definition in 2 of those different ASTM standards. So what it's trying to explain then is that PEX is polyethylene, in our case high density polyethylene, whereby the majority of those polyethylene molecules are actually linked to each other, locking them together in a permanent way, in a way to actually improve properties. So the second quote here from TN17 says, cross-linking of polyethylene into PEX for pipes results in improved properties, such as elevated temperature strength and performance, chemical resistance, flexibility, and resistance to slow crack growth. And these are all important properties when we talk about a pipe being, whether it's being buried in the ground, used in a building as a plumbing system, encased in concrete. These are all important properties, and they all improve when you cross-link polyethylene into PEX. So number one, PEX is a fantastic material and has a lot of great properties that we'll get into in a second. So a little bit of a history and overview. Some people look at plastic, or PEX in particular, as a new material. It was actually first developed in the 1960s and patented, I think, in 1966 by a gentleman by the name of Dr. Thomas Engel, who developed the first methods of cross-linking. And then it was introduced for commercial production, meaning made in factories and sold to customers in the early 1970s in Europe. The original applications were radiant heating, but by the 1980s, people realized the PEX tubing was also a great material for plumbing systems. In the 1980s, that's a long time ago now, so we have a lot of history. And in fact, that's when PEX tubing was introduced into North America, and the original tubing standard published by ASTM, which is called F876, was first published in 1984. So that is a long time ago, almost 40 years ago. So what is PEX? PEX is a high temperature, flexible pressure pipe material. It often comes on coils, as you'll see in a lot of pictures here today, and it can withstand very high temperatures. And PEX tubing systems today are used and approved in codes for a wide range of applications. And these are all pressure applications where pipes can be exposed to high temperatures. So it's quite a list of approvals for one piping material. Now, there are different ways of manufacturing PEX that have been developed over the years, and you've probably heard of this before. Some people call these methods PEX A, B, and C. They're formally known as the peroxide method, the silane method, and the electron beam method. And these letter designations are actually not related to any type of performance rating system. They're actually based on chronological dates of when the methods were developed and introduced. So the peroxide method came first, and in the beginning it was just PEX, and then came the silane method, and then came the electron beam method. So somebody a long time ago decided, let's just shortcut these names and call it PEX A, B, and C based on which came first. But the important thing to know is that PEX tubing produced by each of these methods must meet the same technical requirements as specified in the relevant industry standards that we're going to be talking about today and in the codes. Now, there is more detail about each of these methods, and you can find those details within the PPI TN17 document. Another important thing to know about PEX tubing is the sizing, and I keep saying the word PEX tubing because it is nominal tubing size. The PEX that we use in North America is not IPS, it's copper tube size dimensions, which means the actual outside diameter is 1/8 of an inch larger than the nominal size, but that's the same as copper tubing. PEX tubing also has a standard dimension ratio of 9, which means the wall thickness is always 1/9 of the outside diameter. You don't get that in metal pipe, but the benefit of having a standard dimension ratio is that the same temperature and pressure rating applies to every different diameter. So whether it's a 1/2 inch tubing or a 3/4 or a 3-inch PEX tubing, it's going to have the same burst pressure and the same long-term pressure temperature ratings because of that standard dimension ratio. So that's very much a good thing. And the standards require really tight tolerances on the dimensions. So example here, with dimensions taken from the ASTM F876 standard, it shows a 3/4 nominal tubing PEX. The outside diameter is 0.875 inches plus or minus 0.004 of an inch. That's how tight the tolerances are on PEX tubing. And PEX tubing is interchangeable from all the different manufacturers. The configurations we mentioned before, PEX tubing is normally coming in coil configurations, as you see by the image on the right, a little bit small there, but it's also available in straight lengths. So when we get into larger diameter PEX tubing, 1-inch nominal tubing and larger, a lot of people prefer to use the straight length because they're not maybe taking advantage of the flexibility so much for the very large tubing. But it is produced in nominal tubing diameters from 1/4 to 4. The small diameter tubing is often used for ice maker connections on the back of your refrigerator. And different manufacturers manufacture PEX tubing in different colors. Most manufacturers make it in red, white, and blue. The red, the blue, the white, they're all the exact same material with the exact same capabilities. So if you're buying blue PEX, it doesn't mean it's used for cold water only. It would still have all the same hot water certifications and capabilities. Now, one of the most important properties of PEX systems, of course, is its ability to be safely used in drinking water systems. And drinking water safety is ensured through mandatory testing and certification to this standard shown here, called NSF ANSI CAN 61, toxicological evaluation for materials in contact with drinking water or health effects. The purpose of this standard is actually shown here. It says this standard establishes minimum health effects requirements for the chemical contaminants and impurities that are directly imparted to drinking water from products, components, and materials used in drinking water systems. So this standard has been around, I think, for almost 50 years now, but it does get updated regularly with new requirements. And the standard is actually published by the NSF organization, but the content and the technical requirements are actually derived by a committee made up of a health advisory board, made of microbiologists and government regulators and other types of medical experts. Actually collaborate to form the requirements of this NSF 61 standard. So it's very critical, but the benefit of this is when you're purchasing products that are certified to NSF 61, you can know that they are safe for drinking water safety. And then similarly, there's also a separate NSF standard to ensure that the products are lead-free, and this standard is known as NSF ANSI CAN 372, Drinking Water System Components Lead Content. So PEX tubing systems have never contained lead, but it has been mandatory for the last several years that all PEX tubing and fitting systems must be tested to verify that there is no lead coming out of those components into drinking water. So our safety of drinking water is assured by those mandatory certifications. Let's get into some other properties now. And one of the big benefits of using PEX as a piping material is its flexibility, the fact that you can just simply bend it without using an excessive number of fittings. So the minimum bending radius, it's slightly different depending on the manufacturer, but it's in the range of 6 to 8 times the outside diameter of the tubing. And that's a fairly tight bending radius, as you'll see in some of these pictures here. And the way that works numerically, if you look at the table, for 1 inch diameter tubing, which actually has an outside diameter of 1 1/8 of an inch, if you multiply that times 6, then you come up with a minimum bending radius of 6.8 inches. So that's how tightly you could actually make a 90-degree sweep with 1 inch tubing. For 1/2 inch tubing, it's much smaller than that. So this really helps to save a lot of time for installers and eliminate a lot of fittings. And when you do a sweep with PEX tubing like this, there's practically no pressure loss at all. So it really helps with conserving pressure in the tubing systems and eliminating any extra sources of pressure loss through a whole system. This image here is an example of a tight bend radius that's possible with 3/4 PEX tubing. So quite amazing how you can bend it so tightly without it kinking or collapsing. Now, how that's done in the field is what a lot of people will do instead of using tight 90-degree elbow fittings is they'll simply bend the tubing and snap on a support bend, or otherwise known as a sweep support. As you can see here in these images, those are produced out of metal or plastic components, and you can simply snap those over the PEX tubing to form a 90-degree sweep in seconds without having to do any joints, and really saves a lot of time. And again, there's practically zero pressure loss, as we've seen in research published by Gary Klein, one of the best researchers on the field of pipe sizing and pressure loss. His data has shown that there's practically zero pressure loss when using these sweeps through PEX. Now, another property to pay attention to is longitudinal expansion and contraction. PEX does expand and contract more than metal pipe does with temperature changes, but this is well known and this is easily accommodated in the field through design and installation. The linear expansion rate is about 1.1 inches longitudinally per 10-degree Fahrenheit temperature change per 100-foot length of the tubing. So in the first example then, let's say you installed a 100-foot line of PEX water line, and it was installed on a really hot day like we're having this week at 90 degrees Fahrenheit. So the building construction site is not air conditioned, it's a really hot day. But then when you put this into service, it's going to have service water temperature of just 60 degrees Fahrenheit going through the tubing. Well, that's a 30-degree temperature reduction. So that's actually going to reduce the length of the tubing by 3.3 inches once the cold water is flowing through the tubing. So if you're the person installing this tubing, you have to account for that. Typically, we just do that by allowing some extra slack in the line. In the other example, it's the opposite. let's say you've installed a 120-foot water line at 70 degrees Fahrenheit, a very pleasant day on the job site, but then you're going to be running service water temperature of 130 degrees through that tubing. So it's going to be a hot water line. That's a 60 degree Fahrenheit temperature increase, which is going to result in a 7.9 inch increase in length. So the pipe is going to grow longer and want to go somewhere. So we have to find ways of accommodating that. Here's another picture example here of a large commercial project with PEX tubing being used as the risers. So for the smaller diameter tubing, because it's so flexible, you can simply accommodate that expansion or contraction by putting a loop in the line, as you see in the image on the left, or an offset in the line, as you see in the image on the right. So that easily manages it there. For larger diameter tubing, let's say 1 inch nominal tubing or larger, it's not as flexible, not as easy to do the offsets and the loops. So you may at that point want to calculate an expansion arm or an expansion loop. So showing an example here from the PPI plastic pressure pipe calculator. And this example here, we're going through, well, I'm not showing all the details, but this actually shows how if you go to that calculator, you can do the calculation for an expansion arm, enter in your data, and you enter in your starting and your finishing temperatures, and it'll tell you how to design that expansion arm or an expansion loop, which in many cases is the preferred way, although it does take some elbows. It can accommodate a lot of an expansion through an expansion loop, as you see here. Another property to talk about is the low thermal conductivity, or K value, of PEX tubing. PPI published a report about 9 years ago with data on that for both PEX and PERT tubing. It's called PPI TR48, and here are the summary results. So the K value for PEX tubing is just 2.86. What that means is, if you compare it to the K value for copper, which is 196, that means that copper tubing is 68 times more conductive than PEX tubing. And that takes into account the actual wall thickness of copper tubing versus PEX tubing. So that's a massive difference. And what that means is that PEX tubing can delay heat transfer and delay freezing of water within the tubing if you have a building that's starting to freeze up. So this is really conserving energy, because PEX tubing helps to keep the hot water hot and keep the cold water cold. So it's a very good thing. There's also a PPI document about insulation requirements. Now, it doesn't mean that you can install PEX tubing without insulation, especially in hot water lines. In a lot of instances, you're still going to want to use insulation on those hot water lines to keep the hot in over long periods of time. So there's actually a document we refer you to called PPI TN65, which gives our recommendations for insulation for hot water lines and various types of applications. But the flexibility of PEX tubing and its low thermal conductivity also then help to provide what we call freeze break resistance. And we have a report on that published on the website called TR52. So first of all, it is established then that PEX tubing is less susceptible to the effects of cold temperature. And believe it or not, it actually keeps its flexibility even at very low temperatures, below -40 degrees Fahrenheit or Celsius. The insulating properties help to prevent water in PEX tubing. But if a building is freezing up hard for many, many hours, eventually the water inside is going to freeze. So the good thing is, if it does freeze solid, the elasticity of the PEX material typically allows it to expand without cracking or splitting. So this is a huge benefit. And with the big freeze that happened down in Texas in 2021, people with PEX plumbing systems generally were fine. Those buildings did not leak when the heat came on, when the power came on, and they were able to thaw things out. So this is a huge advantage to PEX plumbing systems over metallic plumbing systems. So that's kind of our intro onto the properties of PEX tubing. Now let's get into the fittings a little bit, and then manifolds, and then some other things we'll talk about here today. So when it comes to fittings, this picture here is not one fitting system. This is multiple fitting systems shown together kind of as a family picture. And there's lots of different options. So we'll get into some of these options and explain them quickly. But it's important to know that all the PEX fittings systems that you're going to see are produced from lead-free brass alloys or polymers that are approved for these applications. So again, the lead-free brass alloys and the polymers must be certified to NSF 61 and NSF 372. And in addition, the lead-free brass alloys must comply with dezinkification resistance and stress corrosion cracking resistance requirements, which are found in the NSF 14 standard. and those are also required in certain plumbing codes as well. So the alloys that are used for PEX fitting systems today are very remarkable, very high performance alloys that not only give you the lead-free safety, but also really high performance and corrosion resistance. The polymer fittings must meet the same standards, of course, and the typical materials that are used in most polymer fittings are polysulfone or polyphenylsulfone, which are thermoplastic polymers known for high strength, toughness, ductility, resistance to chlorine, and other water disinfectants as well. So they're fantastic polymer materials, and they've been used in PEX plumbing systems for close to 20 years now. And then when it comes to distribution manifolds, very similar. A lot of manifolds are made of the same polymer materials that the fittings are made of, and then some distribution manifolds are also made of copper, which could be soldered or brazed in a factory to provide the outlets of a major trunk line. And here's some images of different styles of manifolds used in plumbing systems. The one on the left, the copper manifold, obviously would require different fittings to be soldered onto each of those outlets. The middle image is a molded PEX manifold that actually has larger diameter connections on the left and the right side and smaller diameter outlets to provide supplies to individual fixtures. So that is a valveless manifold that can be installed up on the ceiling or behind a wall. It's basically a large multi-port T. And then the image on the right-hand side is a valved manifold that's used in a centralized location, kind of like an electrical breaker box, but that's used in what they call parallel or home run plumbing systems, where all your pipes can emanate from a common spot, whether it's hot water or cold water, and you can have direct lines of PEX tubing feeding to every fixture throughout a building. So to wrap up learning objective number 1, our summary here is that PEX tubing has a long history of use around the world for drinking water applications. The fittings and the manifolds are also proven safe for plumbing as well, and that the required certifications that we talked about obviously ensure safety for drinking water and high performance as well. So I'm just going to move over here to another poll question. Let me open up my polls again. Have you designed, specified, installed, or sold PEX plumbing systems before? This is a question for the group to find out how much experience everybody has with PEX plumbing systems. All right, thank you everybody for responding. Let me close this and share the results. So interesting bell curve. We have 50% of people saying yes frequently. So you've already got a lot of experience. Hopefully you're still learning something here today. 17% saying yes occasionally, and 33% saying no, not yet. So that's fantastic. So we've got a really diverse audience, it looks like here. So we appreciate that, everybody. And then let's move on to learning objective number 2, which is providing a little more detail on some of the PEX fitting systems which are available. And like we said, there's a lot of different ones out there, but many of these fitting systems are actually produced to specific ASTM standards or an ASSE standard as well. And all of these fitting systems are tested to harmonize performance testing. So what that means is no matter what the design or the material, all of these PEX fitting systems have to actually be tested to the same, excuse me one second here, to the same standards for performance. So getting into the PEX fitting systems, and this is learning objective number 2. The important standards then that I just mentioned are known as ASTM F877. That is the standard specification for crosslink polyethylene plastic hot and cold water distribution systems, and also CSA B137.5, which is crosslink polyethylene tubing systems for pressure applications. So these 2 different standards, one from the US organization, one from the Canadian organization, define the performance of the joints and the connections and the test methods used for testing all of that. And some of the requirements are burst pressure strength, long-term sustained pressure strength, hot and cold water thermal cycling, and more, but that's just kind of some of the highlights. And then, of course, as we mentioned before, all of the fitting systems, any part of the fitting that touches the potable water must also meet NSF 61 and NSF 372. So we're just going to give a bit of a quick tour into different types of fitting systems that exist out there in no particular order. The first of these that we're showing is known as the crimp ring fitting system. And the crimp ring fitting system is produced in accordance with an ASTM standard known as F1807 or 1807. And that standard actually defines the dimensions and the materials and the tolerances of brass and copper crimp fittings and copper crimp rings, which get deformed and provide a total seal of the tubing around the insert part of the fitting. And that standard has also been around for about 20 years or so now. Now, if those fittings are being produced at a polymer material, they perform in the same way and work with the exact same copper crimp ring and the exact same crimping tools, but the polymer fittings themselves are actually produced to a different ASTM standard known as F2159 that defines the performance requirements of the polymer itself. So very common fitting system out there, works well, has been proven over the years. Now, instead of using the copper crimp ring, there's also the option to use a stainless steel clamp. And that stepless clamp is actually produced according to a different ASTM standard known as F2098. So that's also an option. And the main advantage of using that clamp over a copper crimp ring would be that a different tool is used, and in many cases, the same tool can be used to install multiple diameters of the clamp. So instead of having a separate crimping tool for 3/8, half, 3/4, and 1 inch, you could actually have one tool that does clamps over those different size ranges. But the clamp then basically takes the place of the copper crimp ring with the same insert fittings. Another very popular fitting system is known as the cold expansion fitting using a PEX ring, and this is made to the ASTM standard known as F1960. It's been around for many years. These fittings can be produced under using brass or polymer materials, and the basic premise of this is that a ring of PEX is slid over the end of the PEX tubing itself, and then an expansion tool goes inside the PEX tubing and expands the diameter axially in a uniform way over multiple expansions of the tool. And then the fittings are actually inserted into the tubing at that point. So these fittings are larger diameter than the standard crimp fittings because we've expanded the tubing. And then because of the elasticity of PEX tubing, within seconds it's shrinking back on top of the insert fitting and providing a very tight seal that does get stronger over time. And those tools, most people nowadays are using electric tools to do that expansion, but there are still some manual tools that exist for somebody just getting involved with this market for lower cost. This is another common fitting system known as the press fitting system. So this works similar to the copper crimp ring fitting, except instead of a copper crimp ring, it's a stainless steel press sleeve. And in many cases, the stainless steel press sleeve is captured onto the fitting. So for the installer, that's easy because you don't have to go grab the sleeve separately and add it onto the end of the tubing. And these tools also, or these fittings also get compressed with a tool, which could be a manual hand tool or an electric tool. So you're basically cutting the tubing, inserting the fitting, and then compressing the sleeve, which compresses the tubing over the ribs on the fitting itself. And these fittings can be produced out of brass material or copper alloys, according to ASTM F3347, or polymer materials according to ASTM F3348. So separate standards depending on the material used to make the fitting, but the sleeve is the same. This is another version of a cold expansion fitting. In this one, the PEX ring is slid over the tubing, and then the tubing itself is expanded, and then the PEX ring is pulled, the fitting is inserted, and then the PEX ring is actually pulled back up and over the end of the tubing to compress the tubing over the fitting that goes on the inside. So with this one, you're not expanding the ring, but the ring does get expanded a little bit when you're then sliding it. I call it a ring, it's really more of a sleeve, and then that does get expanded a bit as you're actually sliding it up and over the tubing, compressing the tubing onto the insert part of the fitting. We also have a collection of push fit fittings on the market that have been around for quite a long time for use with PEX tubing. And these push fit fittings come from various manufacturers, but these are made according to the standard known as ASSE 1061, which is a performance standard for push fit fittings. These fittings can be produced in brass materials, as we see here, where you simply just push the tubing into the fitting and it gets locked in there, no tools required. And then these fittings are also produced in polymer materials, but also produced according to the same performance standard, the ASSE 1061. And here's another version of those push fit fittings produced to ASSE 1061. So as we see here, there's a wide range of PEX fitting types available. And as you can see in the image, sometimes we have T's, sometimes we have elbows, but there's all kinds of other configurations as well. from caps to dropper elbows and reducing configuration parts and threaded adapters and sweat adapters. So you can do almost, well, practically any plumbing connection that you need in a job site using available off-the-shelf fittings. And in fact, for larger systems, there's even press fittings available that allow you to go directly from PEX tubing to a press connect fitting, and flange fittings available as well. So the image you see on the right here is actually PEX tubing terminating into flanges going to a flanged valve in a large commercial system. One thing to know about PEX fitting systems, though, is that not all PEX fittings are approved for use with all PEX tubing. In other words, not all the combinations are approved. The tubing manufacturers actually must test and certify each specific fitting design before they recommend them for use with their tubing. So, and what they do is, once they've actually tested each of those fitting designs, and they can choose to test them all or not, but once they have tested a specific fitting design, let's say the F1960 cold expansion fitting with the PEX reinforcing ring, then they would mark the standard designation of that fitting system for which the tubing is recommended on the tubing print line as a way of indicating to the user that this tubing is tested and certified for use with this type of fitting system. So what the user has to do is actually look on the print line of the tubing or the product literature or the packaging for the specific marking of the various fitting systems to find out which fitting systems are recommended for use with that type of tubing. So example here for these images of PEX tubing, the white PEX tubing on the top has been tested and certified and recommended by that manufacturer for use with F1807 crimp fittings, F1960 cold expansion fittings, and another type of cold expansion fitting standard known as F2080. And then the blue tubing on the bottom has all of those three standards on it, plus also the ASTM F2159 standard, which is the crimp ring fitting made of polymer body. So it's on the print line, and the print line repeats at least every 5 feet on PEX tubing. So just check the print line to find out which tubing is compatible with which type of fitting system. That's the best way to know that type of information. So hopefully that helps with that type of information. Let's see if I have another poll question here at this point. Let's introduce a new poll question before we move on to our third learning objective today. And this poll question says, what aspects of PEX plumbing systems might cause you hesitation? I suppose this is assuming that you're new to PEX plumbing systems. This one is requiring some deep thought, I'm sure. Okay, let's go ahead and close the poll. And as we can see, the majority say no hesitation at all. I already specify, sell, or install PEX plumbing systems. Well, that's good. You're already on board with this. 10% say no hesitation. I'm interested in trying it. Well, that is great. 19% say concerns about pipe and fitting installation. Well, let us know how we can help you with those concerns. And the other 10% say concerns about pressure and or temperature capabilities. Well, let's hope in the next learning objective then that we address those, because we're going to be actually talking about that coming up very soon. Nobody with concerns about safety for potable drinking water, though. That's a good thing. Okay, we have about 15 minutes left and one more learning objective for today. And our third learning objective is focused on PEX tubing system standards and code compliance. And we mentioned some of the standards before, but we're going to get into a little more detail on these standards just so you appreciate the amount of testing and research and everything else that is performed in PEX tubing systems to ensure safety. So the standards we're going to be talking about are ASTM F876, ASTM F877, and CSA B137.5. We mentioned all of these earlier. And the reason that these standards are so important, and the standards are published by standards development organizations, ASTM and CSA, and the reason those are so important is because the plumbing codes, such as the International Plumbing Code, the Uniform Plumbing Code, National Plumbing Code of Canada, and the National Standard Plumbing Code, they refer to products as long as the products are meeting a standard. So it's important that the products actually meet a standard, because if they don't, then they're not going to be accepted by these codes. So we're going to introduce some of the requirements of these standards without getting into the weeds too much in the interest of time here today. So ASTM F876 and CSA B137.5, similar standards from different organizations from different countries, essentially are harmonized. And they establish capabilities and test requirements, everything from dimensions, degree of cross-linking, quick burst pressures, long-term pressure ratings, chlorine resistance, UV resistance, excessive pressure temperature capability. Believe it or not, hot bend and cold bend tests are required in these standards, and even the marking requirements are in there, and more as well, without getting into too many details here. So let's just touch on some of these most important requirements in the standards. And by the way, some of these standards then also refer to other standards. So here are two standard test methods that are often referred to. The first of these is ASTM F2023. This is the standard test method for evaluating the oxidative resistance of PEX systems to chlorinated water. So in other words, when people talk about the chlorine resistance, you do the test according to ASTM F2023. And then similarly for UV or sunlight resistance, that's done and that's evaluated in accordance with ASTM F2657, the standard test method for outdoor weathering exposure of PEX tubing. So these standards both come from the ASTM organization, and they get updated fairly frequently to make sure that they're as rigorous as can be. So let's talk about some of these material characteristics and what the standards require. First of all, degree of cross-linking, because as we established early on, cross-linking of polyethylene into PEX is the key to getting better properties, such as high temperature strength and flexibility, chemical resistance, etc. So these standards actually define minimum and maximum ranges of cross-linking, and these are really tight ranges from a cross-linking chemistry perspective. So for each of these manufacturing types, the ranges are defined here. For peroxide methods, it's 70 to 89%, and for the siline method and the E-beam method, it's 65 to 89%. And like I said, those are both very tight ranges of cross-linking as required by these standards to ensure consistency in the material performance. When it comes to the burst pressure, the small diameter PEX tubing materials are actually a lot stronger than most people would imagine. And in fact, the minimum requirement for short-term burst pressure is actually 475 PSI at 73 degrees Fahrenheit. So in other words, if you're actually blowing up a piece of PEX tubing at room temperature, 73 F, that tubing has to withstand at least 475 PSI. And in fact, for all the tubing that I've blown up and seen blown up over the years, it's typically much higher than that. But that is far beyond the pressure that you'll ever see in a plumbing system, because everything else would blow up probably before the tubing would blow up at 475 PSI. And then the standards also require minimum burst pressure at higher temperatures as well. So even at 180 degrees Fahrenheit, the tubing has to withstand at least 210 PSI in a short-term burst test. Now, three of the most important properties for PEX tubing actually are defined in a code known as the Thermoplastic Tubing Material Designation Code, and that is defined within the ASTM F876 standard and also within the CSAB 137.5 standard. So this code defines these three properties here: chlorine resistance, UV resistance, and hydrostatic design stress. And these three properties come from a table because there isn't just a minimum requirement. There is minimum requirements, but there's also different categories of performance allowed for chlorine resistance and UV resistance and hydrostatic design stress. So touching on these really quickly, we have about 10 minutes left here. On the first of these, we're going to touch on chlorine resistance. This has been a mandatory test requirement for about the last 20 years in North America. And it's required that all PEX tubing intended for use in potable water have a minimum extrapolated lifetime of at least 50 years when it's tested in accordance with the ASTM F2023 test method that we mentioned before. And this test method actually utilizes extreme levels of chlorine in the water, as high as 4 parts per million of chlorine in the water, which is far beyond what you find in any drinking water system in North America. The average, I think, is 1.6 ppm across North America. So the testing is done at 4, and the testing is actually done at really elevated temperatures so that you don't have to wait 50 years to run the test. But then when it's all done, what you do is you extrapolate the lifetime of the tubing at an end-use condition of 80 PSI of 140 degrees Fahrenheit. So that means the tubing has to be able to be proven to withstand at least 50 years of 80 PSI and 140 degrees Fahrenheit at a very high elevated level of chlorine. Now there's 4 different categories of performance that get recognized in that material designation code. A 0 means it's not tested or not performance. not rated, but that wouldn't be allowed for potable water. The requirement for potable water is at least a digit 1, which means the tubing is tested and certified for chlorine resistance and a so-called intermittent hot water system, where you have up to 6 hours a day of hot water exposure of the PEX tubing. And then the categories 3 and 5 are more applicable to hot water recirculation systems and commercial type of plumbing systems. When it comes to UV resistance, this is important because history has shown that excessive exposure to ultraviolet light coming from sunlight can actually damage PEX tubing. It doesn't damage it in the short term, but what it'll do is actually reduce the ultimate life of the tubing and potentially reduce its chlorine resistance or its high temperature resistance. So it's important that people don't leave PEX tubing out in the sun too long and accidentally expose it, because then that can actually reduce its lifetime. And you'll have dissatisfied customers that way. So please don't store your PEX tubing outdoors uncovered like you see in this image here on the right. That is completely prohibited and not allowed. So PEX tubing is all tested in accordance with a different ASTM test method called F2657, which is based on natural outdoor exposure down near Phoenix, Arizona, which is considered the worst place in the United States for sunlight or ultraviolet light exposure. And tubing samples are actually mounted on a board facing south, outdoors in the desert, essentially. And if the manufacturer is claiming that their tubing is going to have a resistance of 2 months or 3 months or 6 months, then you actually literally leave the tubing outside in the sun for that long, and then bring the tubing back inside of the laboratory and repeat the chlorine test to make sure you didn't lose a significant amount of chlorine resistance. So without getting into all the details, it's based on real testing. And there's 4 different categories of performance for UV resistance as well. Again, a 0 means not tested or not rated, a 1 means 1 month, a 2 means 3 months, and a 3 means 6 months or more of minimum UV resistance. And digit 1 is the minimum requirement. So what that means is that all PEX tubing used for plumbing systems must have at least a 1 for UV resistance. Another important criteria, of course, are sustained pressure ratings for PEX tubing. And the requirement from the standards is that PEX tubing must demonstrate long-term pressure resistance of at least 160 psi at room temperature and at least 100 psi at 180 degrees elevated temperature. PEX tubing systems are also tested for resistance at temperatures all the way up to 200 degrees Fahrenheit as well. And then when they do that long-term pressure testing, a design factor is applied to the PEX tubing. And essentially what you do is you derate the tubing. Without getting into all the details here, the way this design factor is applied to PEX tubing, this results in the final 2-character digit that's part of the material designation code. So the 06 is actually an indicator that the PEX tubing has shown a minimum hydrostatic design stress value of 630 psi. That doesn't mean 630 psi gauge pressure of water inside the tubing, but it means pounds per square inch of actual strength of the material itself. And that's with a design factor of 0.5 applied to the tubing. So don't have time to get into all the details in that right now, but it's quite rigorous. The final property we're going to be talking about from the standards has to do with flame and smoke spread ratings. And different codes have different flame and smoke spread ratings, but it is a requirement typically in commercial construction that if PEX tubing is to be installed within a return air plenum that requires non-combustible materials, then the tubing must demonstrate a flame spread of less than 25 and a smoke spread rating of less than or equal to 50. In the Uniform Mechanical Code, that requirement is that the tubing must be tested in accordance with ASTM E84 or UL 723. For the 2024 version of the Uniform Mechanical Code, it's also going to allow testing in accordance with UL 2846. Slightly different test method. And in Canada, the flame and smoke spread testing is tested in accordance with CAN ULC S102.2, which is slightly different test method. So these values are generated using something called a Steiner tunnel test, and you have an image of that in the lower right hand side here. In the International Mechanical Code, it does allow or requires testing again in accordance with ASTM E84 or UL 723 or UL 2846, which is already an acceptable test method according to the 2019 and earlier versions of the International Mechanical Code. So that brings us to the end of our third learning objective. I went through some of those parts kind of quickly, but of course, if you downloaded the slides, you can read all the details there and find the rest of the information on the PPI website and in other publications we have in terms of the details or more details of flame and smoke spray testing and things like this. But the important thing is, to wrap all of this up, is that all the US model plumbing codes and the Canadian National Plumbing Code of Canada, they accept PEX systems as long as they're certified to the standards. So in the US, it's ASTM F876 and F877 for the fitting systems, and CSAB 137.5 is also accepted in US codes, and the National Plumbing Code of Canada accepts PEX systems when certified to CSAB 137.5. And you'll find if you read each of these codes, you'll find that PEX tubing and fitting systems are fully accepted in all the plumbing codes for residential, commercial, and other types of applications as well. So fully accepted, you can use it for any of those applications once you're comfortable. To wrap up today, we're going to have another poll question in a second, but we did want to let you know that if you're really interested in learning more about PEX systems right now, you can go to our website and download a lot of this information in various ways. If you go to the web page of the Building and Construction Division, it looks like this. And right below where it shows our mission, you'll see that there's actually a web page for each of the materials that we represent. So if you click on the cross-linked polyethylene web page, it'll open up, it'll look like this. It's this information plus some more. It'll show a list of all the PPI members with PEX systems and links to their websites on the right-hand side. And then at the bottom of that, if you want to read more about any of the standards that we talked about today, those are live links to those standards. So if you want to read more details about ASTM F876, just click the link to it from the BCD webpage, and that'll take you right to an ASTM webpage all about F876. And if you want, you can even purchase the standard from ASTM as well to have all the details of the testing. Okay, I've got one final poll question. And this one is just to learn a little more about our audience here today. This one says, I am involved with the following types of plumbing projects. If we could take a few seconds to answer this one, that would also be great. Are you involved with just 1 and 2 family? Also multifamily maybe, hotels, condos, apartments, schools, or other commercial or institutional projects? And this is one where you should be able to select all of them if you're involved with all of these types of projects. And I think the reason we have this poll question at this point of the presentation is that PEX is approved for all of these applications. So you could be using the same types of pipe and fitting systems for all of these types of projects. All right, let's close it up and share the results. So nobody on the call here today involved with schools, but a good number of people involved with other types of projects. So very good. Thanks very much for sharing that information with us. So with that, we're going to wrap it up. Again, back to our course learning objectives. Today, we covered the first 3 of these learning objectives. In part 2 of this presentation, which is going to be in late August, we're going to describe 3 distinct plumbing layouts using PEX and compare the advantages of each. That's trunk and branch, home run, and zone plumbing systems. And then we're going to talk about test data from published research to demonstrate how the design of PEX plumbing layouts can improve system performance and provide faster delivery of hot water with reduced water waste, all very important things. And then the final part of the next presentation is to show how to access industry resources about design and installation of PEX plumbing systems. So that presentation is going to be coming on August 24th at the same time as today. So that's going to be called Designing PEX Plumbing Systems to Optimize Performance and Efficiency, Part 2. So we're going to be setting that up and go to webinar very quickly and start promoting that presentation in the next week or so. So with that, we thank everybody for attending today. There is a closing survey. If you could spend a couple of minutes taking that survey on the way out, we would greatly appreciate it. Again, if anybody needs a certificate, feel free to contact me with my email address there. And with that, we will wrap it up. And thanks everybody for joining today, and have a great rest of the day.